Awesome. Hello. Thank you for coming today. Hope it's been a good one so far. Hope the party was good last night. I was in bed for 9:30, like a good boy. Yeah, too tired from holiday. So yeah, today I want to talk about developing with ARcore with Unity. So if you don't know what ARcore is, it's Google's own AR SDK, and with Unity being very platform agnostic, we try and target every single platform we possibly can on the planet, like about 30 platforms we support right now. ARcore is one of them, and we're really pushing ahead, if you've not realized, in VR and AR, and we really truly believe it's the future. And I cover most of the XR, as we call it now, stuff for Europe with Unity. So yeah, hey, I'm Josh Naylor. I'm a technical evangelist for Unity, and it's exactly as preachy as it sounds. So I basically travel all around and do technical demos and teach people how to use Unity, show new features, visit a lot of studios, see what they're doing with Unity, and help them out in any way that I can. So if we kind of look at what AR is, what's happened so far, we've been pushing VR for so many years, and AR's kind of come a bit more ahead in the last 1 or 2 years, really, with different technologies being used. If we look at what View4 has done with marker-based tracking, and things like Pokemon Go have really brung AR to the mainstream. If you said to my mum like a year ago, what's AR, she would have no idea. But if now you say like, oh, do you know what augmented reality is? Do you remember Pokemon Go? And she says, oh yeah, I know that. Yeah, it's when something digitally is in the real world. Like, to a consumer, to know what that is pretty good, pretty big, right? And then also we've been pushing ahead with head-mounted AR. HoloLens being one of the best ones so far, and then a lot of hype around Magic Leap. And a lot of people think that when we look at this like little graph here that I made, and it's fairly common. We've got the real world at one side, the virtual world at the other. We've got computer graphics, got real life, and then we've got what was it? RR for real reality, VR for virtual reality, and AR is in the middle, and that's where everyone seems to put it. But I want to kind of challenge that and think that it's more of a bigger scale, because it completely depends what we do with our applications and the technology available to make it as a different scale. So I want to go through a few things that Google does and also Apple does with ARKit that can put it somewhere in between the two, rather than just bang on in the middle. It can go either side. So this is what Google are doing with some of their AR stuff.
3, 2,
okay, we'll just do this.
1. Look at that.
It might seem gimmicky to some of us, but this kind of experience in a classroom can take kids and transport them and bring different things to them. A virtual reality, we might take them somewhere else.
Genes, things that we can't see.
So if we was using virtual reality, we would then transport ourselves to that location. But in this example, with AR, anything can be brought to the classroom instead.
By just telling them about it.
And that's what Google are really trying to push with, as well as other AR frameworks. So what's really cool about ARcore? First of all, motion tracking. So what happens here is you've got your mobile device, and it's taking points all around the room. So, for example, if I'm holding it up and moving it around, it's taking all of these points and using them in the virtual world. It's using my phone's gyroscope, rotation, accelerometer, and judging where I am and the depth sensor in the camera into position in the world. So it's estimating all of these kind of points, and then saying, right, it's building up this like mesh of the 3D world. Kind of like if you've tried HoloLens and you can see the mesh forming all around. It's exactly as it's done, but more point clouds. And here's a very small example of what it would look like. As you're walking around, you've got your sofa and it's getting those points, and then it gains like an image of the world. What it then does with these points is judges where it can find flat horizontal surfaces. So it finds groups of those points that it's been trying to build up the world, and makes a flat horizontal plane for you to be able to put points on and interact with. So we can see here we can also have multiple levels. So we've got the floor, we've got the table, we've got the chair height. And we can use these as interactable surfaces because it's gained them and it's saved them in the world. So then I could turn around and point them and build up my world somewhere else. But then I can come back around and they will be in the same place. And then what's really awesome is this thing called light estimation. So this is a way of getting the light from the real world and using the camera and applying that to the computer-generated graphics in the world. So it's applying any lighting that you've got in the world, the intensity, the color, the reflections, and applying them to the objects. Just like this example, so if you've got two cats, one in the light, one in the dark, it's more immersive and it feels as though it's more integrated into the real life because the real lighting has been applied. And I just want to show you some examples of that. If anyone knows Mike Rose, please send him a picture of this. This is from his talk yesterday. If you saw it, it was very grounding for indie sales figures. So with Google, we can just go into our camera, we can go into our AR stickers, and what we're going to do straight away is just build up an image of the world. And you can see here that as I move it around, it's getting a surface for me. And then I can simply grab my Stormtrooper, bring it in, and we can see those white dots, and that means that it's found the horizontal plane. We can drop it in, and we've got a nice little Stormtrooper here. And what we can notice straight away is, first of all, is flat on my plane, and I can change his size and scale and rotation, so I can interact with him straight away. He's got a shadow, which matches what he's doing, and we can bring in BB-8. And if I just place my hand over, or if the lights were dimmed, for example, we would see the reflections would change on the different objects. So we can see that is specular. There we go. So we can see the specular. Ah, nice one, cheers. And he changes kind of like the tone of what it's like. So if you turn the lights back on, if that's possible, we can see it becomes a lot more bright and specular. We can do things like grab 11, eat some waffles. And then we can move up to other examples. So we can maybe scan this, try to put Dustin on top of there, and put them in the real world. And then it gets a bit full for us. Okay? So this is what Google just made part of their camera app. And now I want to show you how to actually do that in Unity. So this is the SDK, which you can basically download for free as long as you're using Unity 2017.3 or higher, which was released in December. We've got the ARcore SDK preview. We're in preview 2 right now, and they're looking to release fairly soon. You need a minimum Android SDK of version 24, which is Marshmallow. ARcore capable devices. Right now there's only 3. It's the Pixel 1, Pixel 2, and the Galaxy S8, I believe. And then in your Android settings in Unity, just making sure that you've got multi-thread rendering off, XR settings enabled, and then a minimum API. And we can get going. And this is the example that they give us straight away. So what it is basically everything that I've just shown you with the AR stickers, but using Andy Android. So again, we're scanning the area, and we can see here we're building up a mesh, we're building up a point cloud. You can see the smaller blue icons, and that's building up the 3D world on the y-axis, and the red mesh is building up horizontal planes. And then we can put some Andy Androids in. Okay. So what we can do here is move around the scene. We can look over here, we can try build up another area here, put some down. And then I can come back round, and because it's remembered the full world and mapped out this area, that they're still in the exact place that I placed them. And I'm building up even more of my point cloud now. You can see here. And the ones in the back corner that were meant to be down there, they're still there. They've saved in that position. OK? But this doesn't feel that interactive. Right now, we're just placing them in the world, and they're just like, yep, we're there. We'll just save. We're just static objects. What can we do, and what's the best practice to make it more interactive and make it feel as though they're part of the real world? So in this example here, I've stolen one of our cat models from one of our games, Trash Dash. And again, I'm going to build up my world. And these are just some dancing cats. But what I've done is used Unity's API for look at, and I've made sure that they look at the camera at all times. So now I can move around here, and then they follow me around. So if you had a character with just like a different skeleton setup, you could just make the head move around. So their body could be static and then move the head. And again, this feels now a lot more immersive because I've got these cats following me around and looking around the scene. And everything that I'm doing is just with one hand. You don't have to have controllers, you don't have to be messing around all the time. All I'm doing is moving. And you imagine giving that to a child. I've given this to my 6-year-old little boy, and he just places cats all over the house. And then what we can do is we just shoot a raycast when we touch the screen, and they can start dancing. And it's all these extra design considerations taken into account when we're developing for AR now. We need to think of like, how are these going to react when I move closer up to them? So what we could do is put a trigger area, so when the camera moves up to the cat, for example, it could start playing a different animation because I've moved up to it or further away. Or it could get bigger or smaller. And it's thinking about how are we going to interact with these computer objects, but in the real world. Dance, dance, dance. Sweet. So that's really, really basic stuff. But if we're looking at what I talked about earlier on with plane finding, we've done that easy to do, came part of the thingy. The motion tracking, again, I can walk around the scene and everything follows my character because I've said follow the camera at all times. The next thing is the light estimation. This is really awesome stuff. So we can grab stuff like environmental mapping. So these examples here are using different shaders on the computer-generated graphics to get the light around it. So this red and purple, I don't know what they are, like beanbags, and apply that to the Android on the left. We can also apply a reflection probe onto the character, and it's taking the red jacket from this person here, and it's applying a reflection probe onto my character every frame to give it this really metallic looking effect. And again, we can show you how this works. So this example here on one of our Bitbucket of one of our evangelists in Australia, he's applied some custom shaders, which again, freely available. And we can, again, it saved everything where I was. We can use these shaders on these cubes here. So as I move around the room, you can see that it's taking the environmental mapping and the skybox and applying it to these objects. So on the Android here, as I move around him, it's getting the blue light from here. As I move around this side, all of the other objects are getting the rest of the pink of the scene. And we can do this again with our Carl robot. So I can move up to him. And we can see, like it's shown on the video, that it's taking and applying a skybox to him in Unity, judging by the reflection of the rest of the room. And it's just taking that camera back buffer. So, like I just said at the very beginning, we've got the real world and we've got the virtual world. And AR is not just this middle line all the way through. We can take marker-based, environmental mapping, light estimations, plane finding, motion tracking, and making it such a bigger gap and giving all of that, using all of the technology in the right way to make it different for the user. So there's some various different resources on Twitter. We're looking at ARcore and Made with ARcore. Blogs. Google have some amazing best practices blogs, what they've been doing with their Daydream Labs. We've got our forums. People have been doing experiments, so experiments with Google.com AR, and this is ARcore. And here's just a few of those examples on that. So this is using 2D sprites, but putting them in the real world. And again, what I did with the cat model, making them face the user at all times. So it's getting the point clouds and applying them to different worlds. This one's taking vertical planes instead of horizontal planes and putting kind of like portals to other worlds through them. And as you might see, that none of these are actual games. They're all like experiences and interactions, a way of exploring the world. And this one's really cool. This is a way of applying post-processing to the back buffer of the camera so that the object itself is more highlighted. So as we move and get closer to the object and move around quicker, we play with the depth of field of the back buffer of the camera. We make that the image pop out a lot more and apply like a lot of color contrast to the background, which is really sweet. And that's my time up. Thank you very much. If there's any questions, feel free.
Round of applause, please. I think we've got time for one question, if anyone's got a burning question. Oh, yeah, okay. Lovely, thank you.
You said there's depth sensing. Does it support occlusion? I noticed sometimes the things would be showing through objects that would be blocking, but like, can you add that support in yourself?
Half and half. So they're working on that mainly at Google internally to make it a lot better, because we're still in developer preview too. It's not really possible right now on the Unity side. It's more waiting for them to do it. ARKit you can. It's a lot, I guess, further along because we're working on that version. We're working on the ARKit version with Apple, and Google are working on their own ARcore version. So yeah, it's coming. Not yet though.
Okay, thanks.
Lovely, thank you.
And yeah, if people are interested about ARKit, it's gone now, but we've got a blog post and we're working on a thing called VR Interface, and that's a framework to do ARKit and ARcore together in Unity. So that's in a very early experimental, but it's freely available on GitHub. So just just search ARKit, ARcore, Google, Unity, and there'll be a blog post about that. Cool.
Are you around for the rest of the day?
I'm around for the rest of the day. We've got a Unity booth, second floor up, so feel free to come visit, grab some swag and stickers, badges and
What
stuff.
swag you got?
Stickers, badges, bottle openers.
All right, now I'll be up there. Thank you very much.
Thanks very much.
Right, round of applause. Lovely, thank you guys.